In 2007, a radio telescope in Australia recorded a single burst of energy. It lasted 5,000ths of a second. In that fraction of a moment, it released more power than our sun puts out in 3 days. And then, it was gone. We have been looking for the source ever since. We have not found it. By the end of this video, you will understand what a fast radio burst is. You will learn what we know, what we don't, and why some of these signals repeat on a schedule from somewhere we cannot see. This is one of the deepest unsolved mysteries in modern astronomy, and it keeps getting stranger. The universe is loud. Stars hum, black holes scream, galaxies whisper across billions of light years. We hear all of it, in a way, not with ears but with antennas. Massive dishes pointed at the sky, listening for radio waves that have traveled for unimaginable spans of time before arriving here. Most of what we hear, we understand. Pulsars rotating like cosmic lighthouses. Quasars blazing from the hearts of distant galaxies. The faint background glow left over from the beginning of everything. The sky has patterns, rhythms. Things behave the way physics says they should, and then, sometimes, something doesn't. A fast radio burst is a flash of radio energy that lasts milliseconds, barely the blink of an eye, but carries the energy output of hundreds of millions of stars. They come from outside our galaxy. Most come from billions of light years away. They are among the most energetic single events we have ever detected, and most of them happen exactly once. One burst, no warning, no echo, no source visible at the location they came from. We have cataloged thousands of them. We still don't know what most of them are. The first one was found by accident, buried in archived data from a telescope in Australia, 6 years after the fact. By the time anyone realized what it was, it had already vanished. No one could go back and look. No one knew where exactly to look anyway. The position was a smear across the sky. It could have come from anywhere in a region containing millions of stars. For years, no one knew if it was real, or a glitch, or interference from a microwave oven down the road. That last one actually happened. A separate set of bursts at the same telescope turned out to be the staff opening the kitchen microwave before the timer finished. Real signals from space in the staff fridge looked the same to the antenna, so astronomers built better detectors. And then more bursts came, from other telescopes, from other parts of the sky. Slowly, they had to accept it. These were not glitches. The universe was sending us something, briefly, without warning, from everywhere. And then, in 2012, one of them repeated. A burst came from the same point in the sky, then another, then dozens, from a region so far away that the light had been traveling for 3 billion years before it reached us. Whatever was making the signal had been making it for a very long time, and it was still going. That should not have been possible. Most of the theories scientists had built for FRBs assumed they were one-time events. A neutron star colliding with a black hole, a magnetar in its final death throes, a cataclysm so violent the object that caused it would never exist again. Those models can explain a single burst. They cannot explain a source that keeps bursting. For years, decades, maybe longer. Then it got stranger. In 2020, astronomers discovered that one of the repeating sources didn't just repeat, it followed a schedule. 12 days of silence, 4 days of activity, then silence again. 16 days total, every cycle. Like clockwork, like something with a rhythm, something keeping time. That kind of regularity on that kind of time scale has no obvious natural explanation. Whatever is out there, it is not behaving the way we expect dying stars to behave. The leading explanation is magnetars. These are neutron stars with magnetic fields 1,000 trillion times stronger than Earth's. When their crust shifts, when the surface of a dead star cracks, the released energy could, in theory, produce something like a fast radio burst. And in 2020, for the first time, we caught a magnetar inside our own galaxy doing exactly that. It was weaker than the distant bursts, but the signature matched. For some fast radio bursts, The case looks closed. Magnetars. Confirmed. For others, it doesn't fit. The repeating sources are too consistent. The energies are sometimes too high. The patterns are too clean. Other ideas exist. Neutron stars orbiting black holes with a burst released every time the orbit reaches a certain point. For now, the honest answer is that we have several possibilities, and not enough data to choose between them. We have built telescopes that detect dozens of these signals every day. We have mapped where some of them come from. Galaxies that look perfectly ordinary, with no obvious source of the energy that left them. We have proven that at least some of them are made by dead stars. We have proven that some of them follow patterns we don't understand. But every time we get closer to an answer, the signals get stranger. The sources get harder to explain. The mystery deepens instead of resolving. Somewhere out there, in the dark between galaxies, something is broadcasting. Maybe it's physics we don't yet have words for. Maybe it's the corpse of a star screaming through the void. Maybe it's something else. We are listening. We don't know what we're hearing. If you want more questions like this, subscribe. There are deeper things waiting in the dark.